Hi guys, and welcome to another video. Today we're going to be looking at trigonometry, solving 2D, 3D triangles, and we're going to be looking at the trig ratios, sine, cosine, and the area rule. The question that we're going to be looking at is from the February-March 2018 paper 2, and it reads as follows. It says PQ and AB are two vertical towers. That's important. Vertical towers means that we are going to get the formation of a right angle triangle. From point R in the same horizontal plane, Q and B are the angles of elevation. To P and A are theta and 2 theta respectively. AQR equals to 90 plus theta and QAR equals to theta, QR equals to X. The first thing that we should do is make sure that all the information is on our diagram. So if we check, we have 90 plus theta, theta to theta, QR equals to X. So always read, and read. That is very, very important. Now let's look at the questions. Determine in terms of X and theta, QP. Now, when we look at QP, what we need to do is, even if it's a 3D problem, you need to isolate that particular triangle and solve for the unknown side. Now remember that there's two types of triangles that we can be given. It can be given a right angle triangle or a non-right angle triangle. So if we have a right angle triangle, like here, QP, let's just quickly look at that. QP forms part of a right angle triangle. And as you can see here, we have in a right angle triangle, our reference angle is theta. So the opposite side will be QP. The hypotenuse is PR and the adjacent side is X or QR. So when we have a right angle triangle, so for 6.1, remember now for right angle triangles, we need to know our trig ratios. So if we have theta, that is my opposite side. Remember, theta is my reference angle, and opposite my 90-degree angle is my hypotenuse, and then the remaining side is my adjacent side. So once again, what I normally do also is isolate this particular triangle, and you can redraw it. So PQR, if we redraw this particular angle, so we got PQR, or this triangle I should say, PQR, we got theta and X, theta, and remember QR is equal to X. Now what do they want? They want us to determine in terms of X and theta QP. So we need this side over here. So we need that side. So that's our opposite side. And X is our adjacent side. So looking at the acronym SOHCAHTOA, remember the opposite side and the adjacent side, we will now use tan. So therefore our solution will be tan of theta is going to equals to QP all over X. Therefore QP will be equals to X times tan of theta. And that's the solution or answer for our first question. Let's go look at the next one. 6.1.2 QR. Now for QR, let's go look at that. So QR, let's use a different color. So QR is this side of this triangle here. They want us to represent it in terms of X and theta. Let's not forget the question. And let's look at the triangle that we have here. So as you can see, the triangle that we have here is a non-right angle triangle. Now for a non-right angle triangle, you can either use the sine rule or the cosine rule to solve for an unknown side. So let's look at the information that we have. So we got theta, and we've got X, and we've got 90 plus theta. So let me redraw or isolate this particular triangle so that we can have a look at it again. 6.1.2. So for 6.1.2, let's redraw this triangle. So that would be AQR. So we'll say A, Q, and R. So it looks as follows. So A, Q, and R. And let's put our information. So we got theta there, 90 plus. So that's theta, and that's 90 plus theta there, right? AQR, and let's not forget this, X. So what do we have here? We've got a non-right angle triangle. As you can see, we've got two angles here and we've got one side. So therefore, this particular non-right angle triangle, to solve for the side AR, we want to find the side AR. So this is a classic case of using the sine rule. So let's quickly just revise the sine rule. The sine rule is as follows. It says sine of A over A equals to sine of B over B, sine of C over C, or you can write A over sine A equals to B over sine B equals to C over sine C. And once again, the sine rule is for a non-right angle triangle. So if I have a triangle like so, A, B, C, and remember that's opposite there, so that side will be called A, small letter A, small letter B, and small letter C. So a classic case is when you are given an angle and its opposite side, then we will likely use the sine rule. So once again, if you're given two angles and one side, you can now find the other side. Or if you're given two sides and one angle, you can find another angle. But always look for an angle and its opposite side, then you know you're most likely going to use the sine rule. Now we can solve this particular question because we have an angle and its opposite side, which is given as follows. And here we got the given angle and we want to solve for the opposite side, which is AR. Because it tells us here in the question, determine in terms of x and theta AR. So learners, we can now write that down. Now, another hint is always start with the side of the angle that you want to solve for. So AR, so you're going to say AR all over sine of 90 plus theta, sine of 90 plus theta, which is now going to equal to x over sine theta. So we got x over sine, make AR the subject of our equation. AR equals to x times sine of 90 plus theta all over sine of theta. So what do you notice here? Sine of 90 plus theta. So we can leave our answer like this because we've represented in terms of x and theta, but we can simplify further. Sine of 90 plus theta is cos of theta. So we can say x times cos of theta all over sine of theta. So therefore AR equals to x times cos theta all over sine theta. Let's look at the next question. Now in the next question it says, show that AB is equal to 2x times cos squared theta. So let's go look at where is AB situated here. So if you look carefully now, learners, we have the following. So there's AB here, right? And it is a part, well, we can clearly see that it's a part of a right angle triangle. For a right angle triangle, then we are going to use, remember, trig ratios, sine, cos, and tan. So let's have a look at that. So what do they want us to find? Once again, it said show that AB is equal to 2x cos squared theta. So AB, so therefore we want to solve for that side. And there's our reference angle here. So that makes this the opposite side. Now look at what we've already solved for. So we've already solved for AR 6.1.2. So therefore the other side that we are going to include is AR. So that will leave us with the opposite over the hypotenuse, which is going to be sine. So there's it here. Sine is opposite over hypotenuse. So once again, we'll say sine of 2 theta because that's my reference angle. Sine of 2 theta. So 6.2, we'll say sine of 2 theta equals to the opposite side, which is AB, all over AR, which is the hypotenuse. Let's just go double check that. AB, there's it here, and AR, right? So now let's make AB the subject of our equation. So now we're going to say AB. So if we just do a simple cross multiplication there, AB is going to equal to sine of 2 theta times AR, which is now going to equal to AR. Let's go and substitute AR. So that'll be sine 2 theta times, remember now AR is going to be x times cos theta all over sine theta, which is equal to, now what do you know about sine 2 theta? That's a double angle. So we're going to write down 2 sine theta times cos theta, x times cos theta. So that's going to be all over sine theta. So let's look at that. So what happens now? Sine theta cancels with sine theta. 2 times x is 2x, and cos theta times cos theta is cos squared theta. So therefore we can conclude that AB is equal to 2x cos squared theta. The last question now. So determine AB over QP if theta is equal to 12 degrees. So AB and QP, let's go look at that. So we solved for AB and for QP. So what is AB? Well, we've just got it here. So this is now going to be 6.3. Let's write down AB over QP equals to 2x times cos squared theta, and QP we've solved for in a previous question, and there's it here. That's equal to x tan theta, x tan theta. Let us simplify. X and x will cancel, so therefore we're going to be left with 2 cos squared theta over tan of theta. Remember they told us that theta is equal to 12 degrees, so let's substitute. We'll write 2 cos 12, or cos squared of 12 degrees all over tan of 12 degrees equals to. So our answer is 9. If we round off, we've got 9 units. Learners, if you haven't subscribed already, please subscribe to JL Maths. You can also catch all the videos on jlmaths.com, like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.